Welcome back, everybody. We are going to do problems 7 through 12 on this second page of the review. So when we start this, they're asking us to find the measure of angle 1, and I noticed that this guy, these two angles are marked the same, so this angle must be 30 degrees. So it looks like I'm dealing with an isosceles triangle, so that I would know that angle Q plus angle R plus angle S will equal 180 degrees, because that's the measure of all the angles of the interior on the interior of a triangle. So angle Q is 30 degrees, angle R is 30 degrees, and angle, we'll call it angle 1, equals 180. So combining those, I get 60 plus angle 1 equals 180, and when I subtract the 60 across the equal sign, the measure of angle 1 is going to be equal to 120. Right. In this next example, first thing I would try to do is make sure that these triangles are congruent to one another. I do know by vertical angles that these two angles are congruent, and right now I've got angle side side, which does not prove these triangles congruent. I do know that angle X and angle X must be equal to one another, so therefore this angle is the same as that angle. So it looks like I can prove these triangles congruent by angle side, even though I've got this extra side information. So if the triangles are congruent, then I can say that angle Y is 75 degrees. And then I noticed that when I'm looking at this, that I've got an isosceles triangle, so this angle here must be congruent to that angle, which makes these two guys congruent. So therefore, looking at this triangle, this measure of that angle must be x as well. So I'm going to be able to say that x plus 75 will equal 180, since all the angles inside a triangle add up to be 180. So 2x plus 75 equals 180. Subtracting the 75, 2x will equal 105, and dividing by 2, that leaves me with x being 52.5. Right. Moving along here to number 8, use the fact that ABC and DEF are congruent for problem number 8, which I don't see problem number 8. I guess we'll call it problem number 9. Filling in the information that I've got here, the measure angle A is 92 degrees, angle F is 38 degrees, and B is 2 times x minus 1. All right, knowing that information and looking at my congruent statement up here, I can see that angle C and angle F are congruent to one another, so I can call that guy 38 degrees. So now I can add up all three angles in here and set them equal to 180 to find out what they are. So 38 plus 92 plus 2 times x minus 1 equals 180. Combining these two together, I get 130, plus I'll distribute, and then subtracting 2, 128 plus 2x equals 180. If I subtract the 128 across the equal sign, I'll move up here, I get 2x equals 52, and then dividing by 2 leaves me with x equals 26, and that's what they're looking for problem number 9. Right. In the next one, they want us to find the value of h in the triangles if they're similar. If they're similar, then there's a proportion between these guys that will help me find this given information. There are multiple ways to set up this problem. I could say 8 is to 5, using the height of the triangle to the base of the small triangle will be equal to the height of the bigger triangle divided by the base, and I know these triangles are similar because they told me by angle there are two angles in each, and that's enough. Quick cross multiplication, I can cross multiply these and say 5h is equal to 8 times 15, and that gets me 120. And so then if I divide by 120 divided by 5, that will tell me that h has to be 24. And that's what I'm looking for the height of this. The other way you could have looked at this is that one way I kind of quickly looked at this is I looked at this and said, oh, 5 times what gives me 15? So if I did 5 times 3, that would give me 15. If I do 8 times 3, h then could have been 24 as well. That could have been another way you could look at it instead of doing the cross multiplication to solve. All right, the number 11, they're asking me to state if the three numbers can be a triangle and show evidence. So if you remember, when we are proving triangles, we have to check all the sides to see if they're bigger than the third side. So I'm going to start with 7 plus 5 needs to be greater than 4. Well, that's a true statement. Then I'm going to do 7 plus 4 needs to be greater than 5. That's also true. And then 4 plus 5 needs to be greater than 7, which is also true. So this guy makes a triangle. So that one is a triangle because all of these statements are true. Over here, we're going to try the same thing. We're going to do the same test. We're going to say 3 plus 6 needs to be greater than 2, which is true. We can also say that 6 plus 2 is greater than 3, also true. And then the last one is 2 plus 3 needs to be greater than 6, which is false. So that being a false statement, this is not a triangle. All right, down here we're going to determine right, acute, obtuse, or cannot tell. And so first we need to do the test up here, as we did before, to see if it's a triangle. And if I take 3 and 5, the two smaller sides, they're bigger than 7, so this guy is a triangle. And 7 plus 12 is bigger than 13, it also makes us a triangle. That was basically this final step in each of these, that taking the two smaller need to be bigger than the larger side to make it a triangle. All right, so knowing that, I'm going to go through and do kind of like Pythagorean theorem. We talked about this earlier, that if c squared is bigger than a squared plus b squared, we have obtuse triangle. If c squared is equal to a squared plus b squared, it is a right triangle. And if c squared is less than a squared plus b squared, we have an acute triangle. And we already checked to see, just like the previous problem up here, if these guys were triangles, and we did. So this guy is not going to be an option for our answers. So down here I'm going to say 7 squared, and then 3 squared plus 5 squared. 7 squared is 49, 3 squared is 9, and 25. So 49 is bigger than 34, so this guy follows the obtuse triangle pattern for our Pythagorean theorem. In the next one, we're going to do the same thing. We're going to set up our biggest side, 13 squared, and check out 7 squared plus 12 squared. 13 squared is 169, 7 squared is 49, 12 squared is 144, 169 seems to be less than, what is that, 100 and, what is that, 95? Nope, 93. 193, I think that's what it comes out to be. Yeah, 193, and so that makes this an acute triangle. All right, we will be back to finish the next set of examples very